Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh and in this video we'll continue to learn about time delta in Pandas. So we'll look at operations such as subtract, multiply, floor division, mod, divmod. We looked at subtract in the previous video as well. Here we'll also look at attributes and how to get the ISO format, and finally we'll look at how to get time delta index. So let's get into Jupyter notebook and start coding. Here I've created a new notebook and imported these 5 libraries, and these are the versions I'm using. So to begin with, let's go ahead and first create a series. So the series with time delta values, so pd.series, and in here I'm going to create time delta values, so time delta, and let me copy this so we don't have to type it every time. And here let's add the first one as 1 days 10 minutes, and then the next one let's add 1 minute. So this is, if you remember, this is same as what was in the previous video. I'm just adding the same data points here. Then we have 10 days and 0 minute, and the last one is the same, which is 10 days and 0 minute. So that's the series we have. Must be some, okay, made exact same mistake last time. This must be in a list. Okay, so we have the series. Now we can perform the operations. First we'll look at multiply. So if we multiply x by -1, and then we get the negative values as we would expect, and we see that these have now changed as well. So instead of 1 day and 10 minutes, we have gone back, so it's -10 minutes, so that's why it's 50, and thus the day has changed to -2, and same thing for all others. Next, let's look at how we can multiply this series x with another series. Let's say the series is integers 1, 2 and 3. In that case, when we multiply this, we get for 1 2 we get, so let me pull the series x here. So as you can see, because we had the PD series with only 3 elements, we are going to get values multiplied in only the top 3 rows here, and the rest of the 2 are NATs because there's nothing to multiply with. Now this is already NAT in position at index 2, so we have this 3 NATs therefore. So the only multiplications that have happened are only the index 0 and index 1. So index 1 we are multiplying by 1, so the output is exactly the same. In index 2 we are multiplying by 2, so for the minutes, earlier it was 1 minute, now we have multiplied by 2, so 2 minutes in the output. So that's how the multiply works. Now let's look at floor division. So by floor division I mean, let's say if we have 5 and if you divide by 2 you get 2.5. however, if you do a floor division, that is rounded off, we do not get the decimal part there. So similarly, we have x. If we floor divide this by pd.timedelta, and let's say days is equal to 2, then as we can see, the first one we have 1 day, so it's going to be 0.5 days, and therefore because this was floor, had we used just divide, so let me add that here as well. So had we used just divide, we would have gotten the decimal values, but because this is floor, all those are written as 0. This NAT is NaN, and for 10 days we have the values as 5 in the output. Now moving on, let's look at modulus operator. So how we can get the mod? So for mod, we'll go ahead and create another time delta. X is equal to pd dot time delta, and hours is equal to 11, and we'll create another one, this time using datetime.timedelta, just to make it interesting, and we have hours is equal to 3. Now if we print, let's print x and print y. So time delta, that's the time delta, those are the time delta values we have. Now if we divide, subtract, so let's say x minus y, this is the output we get, which is the time delta, and 11 minus 3, which is going to be 8, and that's what we get here, 8 hours. Now let's look at a couple more such operations, and this is divmod. What divmod is, we get a tuple back. So if we divide, let's say 5 divided by 2, and if we use the divmod, what we get is the your quotient and the remainder. So here we are going to try to use let's say time delta and time delta in, and we are going to convert that to integer and time delta. So div mod, and we'll use x and y. So as we can see, initial values that we had, both were time delta values, but now in the output, when we do perform the operation of div mod, we get integer, we get a tuple back which has the first value as integer and the second value is time delta. Similarly, we can perform another operation which is time delta and integer, and that when we run that through div mod, what we get in the output is time delta and time delta. So let's run this div mod, and here we use x, and for integer let's use a number, say 1,000,000. So in the output, as you can see, we get two values, both of them in the tuple are this time delta values. Moving on, let's look at a couple of attributes that we can use with time delta, and this could be a new heading here. So for attributes, we will first create a series, pd.series, and this series would have the time delta values, and to create those values we'll use pd dot to underscore time delta, and here within a list we'll specify the values, 1 days, 2 hours, and then the next one is 20 minutes. After that, let's add 2 days and 3 hours. So when we look at x, this is the series that we have, which consists of time delta 64 values. Now to access the values within this, we need to use the dt accessor, as we have seen this in a previous video. So we want to type x.dt dot, and then after that we can specify the attribute, which, let's say if we are looking to get the days, so we can type days, and thus we get the 0, 1 and 2 in the output. Similarly, we could add let's say seconds, x.dt.seconds, and thus we get the seconds in the output. Now moving on, let's look at a couple more variations of how we can use this particular accessor dt. We are going to create another series. So here we use 2 underscore time delta. Now we'll create another series with a different method. pd.series, and here I'm going to create a list, and within the list we'll specify pd.timedelta, and here let's say 1 day, 2 hours and 3 minutes. So that's one, and then let's create another one, pd.timedelta, and this could be 0 days and days with a s, and 2 hours and 3 minutes, and then the next one, pd.timedelta, and this could be 10 days, 22 hours and 13 minutes. So when we look at X, that's the Timedelta series we have. And again, if we want to access any values within it, we need to use the dt accessor. So x.dt.days, and we can get the days out. Similarly, x.dt.seconds, and we can get the seconds. Moving on, let's look at microseconds. So x.dt.microseconds, and because there are none here, we get all the values as zeros. Now there are several such attributes. Is there a way in which we can get all of them in one step? And yes, we can do that. So there is a command called components. So if we type x.dt.components, in that case, as you can see, we get a nice table in the output which has days, hours, minutes, seconds, milliseconds, microseconds, up all the way up to nanoseconds. And from this table, if we need just one column of this, we can get that as well. So if you type x.dt.components dot, let's say, days, then in the output you'll get only that column which has the values for days only. So that's how we can get the attributes from a series which has time delta values in it. Now let's look at how we can get the ISO format. And for this we'll create a series, we'll create time delta values again. So x is equal to pd dot time delta, and here we'll add days is equal to 1, hours is equal to 2, and then we have minutes is equal to 3, seconds is equal to 5, and microseconds is equal to 6. Now this is the time delta we have. Now to convert it to ISO, it's straightforward. We just type x dot ISO format, and in the output this is the ISO format that we get. Now next, let's look at how we can create a time delta index. So time delta index with a capital T and a capital I. So x is equal to pd dot time delta index, and within this we can specify 1 days, 2 hours, and another 1 days, 2 hours, and then can add another value here, np dot time delta 64, and here let's say 23, and let's say these are the seconds we are adding. And then after this, let's add a date time dot time delta, and the days is equal to 2, seconds is equal to 24, and if we run this, this is the value of time delta index that we have created, which is a data type time delta 64, and we have the 3 values that we created in here. Similar to this, we can create time delta in another way. So x, let's say pd dot time delta index, and within a list we can specify the ranges, and then we can specify the frequency, let's say frequency is equal to infer, and here we can specify 0 days and let's say 12 days, and let's say another one 24 days. So in the output we see that we have a time delta index created with three values, and the frequency was automatically calculated or inferred as 12 days because there is a gap of 12 days between these. That was it for this video. I hope you have learned how to multiply time delta values with a series, how to perform floor divisions with time delta values, and perform divmod, and how to access attributes of a time delta within a series using the DT accessor. And finally, we also looked at how to create the ISO format and time delta index. In the next video, we'll look at few more combinations of calculations with time delta. Please like, share and subscribe. I hope to see you all in the next video. Thank you.